Hello students, Miss DeLeo here, and today we're going to go over section 4.4 and 4.5 notes. We're going to cover a little bit more on scatter plots, and we're going to get even better at describing scatter plots and their correlation. So, what you guys should remember from your last lesson is you guys had a scatter plot similar to what these that you see down here, and we were able to look at the correlation and describe it as positive or negative or no correlation, and then we were able to put a line of best fit along with that data. But some of you guys were like, hey, Miss DeLeo, what's the difference between a bunch of data points that are really close to a line and ones that are further away? Like, are they still positive? Does that still matter? And I said, yes, we're going to learn about the strength of a linear fit coming up, and that's what we're doing today, okay? So when we were making our line of best fit, we picked 2 points that, showed the trend of the data and they followed the slope and they were appropriate for estimating, just like when we did our little fancy cats activity. Well, or classy cats, my bad. So the truth is that there really is only one exact line of best fit. And sometimes that can be tricky to find. So we always use a calculator to calculate an exact line of best fit using a method called linear regression. And that line of best fit is perfect for the data. It perfectly fits and matches the data. But because we're just starting out, we weren't too concerned about everything being perfect. We just wanted it to be something that could be representative of our data. And that's why we let everyone choose their own 2 points that they like. Now, we can use a measure called the correlation coefficient. This is a number represented by the letter R to help us determine how appropriate a line represents a particular data set. So our correlation coefficient is a number that is between -1 and 1 that helps give us an idea about how strong the correlation is. So I'm going to show you that scale. If you have a correlation of 0, we have no correlation. There's no linear pattern. So remember what that looks like. If there's no correlation, remember you either have a graph that is completely random with points, or you have a graph that shows a pattern, but it is not linear. Either one of these have no correlation, and they would have an R value of 0. So that correlation coefficient of 0 would let me know, like, hey, there's no linear correlation here. Alrighty. A correlation coefficient of +1 would indicate a perfect linear, positive linear correlation. So this would be a perfect positive fit. So every single point would lie exactly on the line of best fit. And same thing over here, we would have a perfect negative fit. Every single point would lie on the line of best fit in a negative direction. But of course, we know that might not always happen, so we have some values in between that help us describe. If we have a correlation coefficient on either side between 0.5 and 0, we would consider that relationship to be weak. Okay, so positive would be weak in a positive direction, negative would be weak in a negative direction. We would expect the points to be kind of far away from the line of best fit, and it would be a linear pattern, but nothing very convincing. Between 0.5 and 0.8 on either side, we consider this a moderate linear fit. So the points are close, but not super tight. They're kind of spread out around the line of best fit, either in the positive or the negative direction. And between 0.8 and 1, we consider this a strong linear fit. So the values points fall very close to that line of best fit, and they look like they fall in a more, direct line. So not only can we describe a graph using positive, negative, or none, but now we can also use these descriptors of strong, moderate, or weak, depending on what we see and what the correlation coefficient tells us. Okay, so our first example says, determine whether the correlation coefficient is positive, negative, or 0. So I'm going to pause this video and give you guys a second to complete examples 1, 2, 3, and 4. Did you get them right? We've got a positive correlation here. We're going uphill. A positive correlation here. We're going uphill. Another positive correlation here. We're going uphill. And over here, we would have a negative correlation. We have a downhill trend. We didn't talk about strength, although you can see some points are more closely gathered around the line than others. So we could say, strong, weak, or moderate if the R value supported that. But without an R value, we can't really say. So we go ahead and answer those questions. Example 2, given the R value, or that correlation coefficient, describe it as positive, negative, or no correlation, and strong, moderate, or weak. Okay, so we're going to look at the correlation coefficient, and it's helping describe the graph to us in an even more precise way. So my first one, I have a negative value, so I would have a negative. I have a negative in front, so I have a negative. And since this value is between 0.8 and negative 1, it is considered strong linear relationship between whatever those two variables are. Okay, so I'm going to pause this video and give you a chance to complete the rest and then check your answers. So did you get them right? Let's double check. I have an R of 0.01. This is positive, and it's weak since we fall into this interval. And an R value of 0.52 would fall here, and it's positive, so positive and moderate. 0.75, and the negative side would fall here, so I've got a negative and moderate relationship. 0.92 would be up here. We've got a positive and strong relationship. So when we have a calculated R value, we can say a little bit more about the graph than we were able to say before. All right, let's move on to example 3. This says, in Mr. Hill's Spanish class, he took a survey and asked his students how many hours they spent studying for the vocabulary quiz. He compared this to the number of questions each student missed on the quiz. X is the number of hours spent studying, and Y is the number of questions answered correctly. All right, so I am going to pause this video and give you guys a chance to plot all your points. We can go by ones on the x-axis and the y-axis. Make sure you label and plot all your points as accurately as possible. So go ahead and do that now. Alrighty, you guys, take a second to look at your graph and make sure that you labeled it the way that I did. And it looks similar to mine. So we should have a labeled x-axis, a labeled y-axis, very clear scale, and points marked as accurately as possible. So now we can move on to part B. It says use 2 points to calculate a line of best fit. Remember, Your points do not necessarily have to be a part of the data set. They can be any points that you would like. And remember, easy points to use are always your y-intercept. So I'm going to pick 2 of them for us so that we can all be on the same page. And we're going to draw a line of best fit through those 2 points. So based off of my graph and off of the evidence that I saw, I chose to use my y-intercept 0.21 because whenever we can use a y-intercept, that's a great idea. And I have a line that went through almost 3 other points. I've got about half of the points below and about half of the points above. So this is a pretty good line of best fit for us, okay? I'm gonna use one other point that falls on the line, and I'm gonna use this point right here, 5, 6. So now we're gonna write the equation of our line of best fit. And if you remember, the first step of writing an equation is always to find the slope. So I'm gonna go ahead and label up my points, and I'm gonna go ahead and write my slope formula. And let's do this. Y2 is 6 minus Y1, which is 21, over X2, which is 5, minus X1, which is 0. All right, so 6 minus 21 is a negative 15, and 5 minus 0 is 5. And negative 15 over 5 can reduce down to negative 3. So there's my slope. Luckily for us, we have chosen a y-intercept as one of our coordinates to write our line through, so we do not need to use the point slope form. We can go to straight to slope intercept form and write our equation y equals negative 3x plus 21. And that is our equation of our line of best fit. Okie dokie, now that we have our line of best fit for our equation, we can go ahead and interpret some things, which is really important to us. So question C says, what do the slope and y-intercept represent in this scenario? So our slope is negative 3. I'm going to zoom in a little bit here. Our slope is negative 3 over 1. And remember, your slope is your change in y over your change in x. And I've got a positive 1 underneath a negative 3. So what we're going to say is for every 1 change in x, what happens to y? Okay? And we're going to use the context of our problem, remembering that x is the number of hours studied and y is the number of incorrect answers. Okay? So here we go. For every 1, and for us we have 1 increase in x. So for every 1 more hour I study, or for every additional hour studied, what's going to happen to y? The number of incorrect answers that you get is going to decrease by 3. The number of incorrect answers on the, I forget if this is a test or a quiz. I'm just going to write assessment. Will decrease by 3. So here's some keywords that you want to make sure that you have, okay? You want to make sure that you have something conveying to me that we have an increase of 1 in x. So for us, that's that additional hour. 1 increase in x leads to a 3 decrease in y. So I've got that right here. And you always want to make sure you use your context. For us, it was hours studied and number of answers incorrect. Okay. Our y-intercept we used is 0, 21 for our line of best fit. And what this means in context is when x equals 0, what does that mean for y? So for us, when x equals 0, x is the number of hours studied. So when you study 0 hours, you can expect what? And that would be to have 21 incorrect answers based on our graph and our data, our model. Okie dokie, let's move on. It says right here, based off of your model, what would you expect your correlation coefficient to be or look like? Make a prediction and explain. I want you guys to do this on your own, and this is something that we're going to revisit in class together tomorrow. So you decide, is it going to be positive, negative, or none? And then would you use the words strong, moderate, or weak? Make sure you include the why because I will call on you so that we can discuss this together, okay? So as long as you justify your answer, we should be good. All right, let's move on to our next example. Question E. If you spend 4 hours studying, how many questions would you expect to miss based on the line of best fit? All right, so there's technically 2 ways you can do this. If you spend 4 hours studying, we can go over to our graph and draw up for 4 hours and hit our line and over. But like we said, showing work in this unit is really important. So let's verify this by using our line of best fit. Number of hours studying is represented by x. So x is equal to 4. So I'm going to plug that into my line of best fit equation to find out the number I should miss. Y equals negative 3 times 4 plus 21. This is negative 12 plus 21. And sure enough, we get 9. So based on our model, if you spend 4 hours studying, we would expect 9 incorrect questions. So sometimes you can use your graph depending on the scale and the accuracy. It's easy. Other times you may just want to use your equation. It's always a good idea to use your equation and show your work. Always show your work if you can. Part F. The person with the best score got all of the questions correct. They missed 0. Use the function to determine how many hours likely they spent studying. Okay, so this person got 0 questions incorrect. That is represented by y equaling 0. So the number of questions they got incorrect is 0. So we can plug in y equals 0 into our equation to find out how long this person studied. We can subtract 21 from each side and get negative 21 equals negative 3x. Divide by negative 3 on each side and see x equals 7. So based on our model, if you miss 0, we would expect you studied for 7 hours. And you can also see that by looking over at the graph. When y equals 0, we see x equals 7. So your equation should verify what you see on your graph. It's always a good idea to show your equation and show your work. Okie dokie, we are going to do example 4 in class together the next time that I see you. So save this example to go over in class. You do not need to do that for homework. What we learned today is we learned further about lines of best fit, how to create them, and we learned that we have even more ways to describe a line of best fit based off of this correlation coefficient that tells us how strongly a line of best fit, the one and only line of best fit, represents our data. So we don't need to be concerned about how to calculate this. We just need to be concerned about how to read this using strong, weak, or moderate. All right, you guys, I will see you in class next week. Bye.